In an earlier video on my channel, I built this prototype of the world's first blowtorch, based on textual descriptions of the blowtorches that were first developed by Renaissance-era glassworkers. I have since used this torch quite a bit in my workshop for a variety of purposes, and am becoming a little more experienced with how they work. After learning some of the lessons the prototype had to teach, I think it's time to build a second iteration. The second torch will be more refined and more capable than the first, and as we go, I'd like to talk a little bit about what I've learned using this hysterical tool. What I love most about the Renaissance blowtorch is its simplicity, and just like the last one, this blowtorch will be composed of a simple oil lamp on a stand. However, this time, instead of wood, I'm going to be making the stand out of scrap copper wire I've rolled square. I'd like to get more practice with copper, and this seemed like the perfect opportunity. I really liked the Greek oil lamp design I went for with my last blowtorch, so I thought I would do the same with this torch, and beyond the lamp itself being a Greek design, I thought I'd give the stand some Greek-esque decoration, in the form of some distinctive spiral copper ears. The ancient Greeks were famous for their meandering spiral patterns, so I thought the form of the ears should pay homage to those. I figured brazing the stand would be a good way to exemplify the capabilities and problems of my first blowtorch. The earliest accounts of blowtorches like this date to the 13th century CE, and as I talked about in the last video on the subject, the device works by simply blowing on an oil lamp flame with a specially designed pipe. This is where the term blowtorch comes from, and the pipe works by creating an extremely fast jet of air to invigorate the flame of the lamp. While practice improves things, I found the flame can sometimes waver. When it's clear blue, everything goes great, but when it flickers yellow, the flame can deposit soot on the metal, which can interfere with joints and requires cleaning. That said, overall, I've been impressed with the ease at which the lamp can solder metal. One thing that surprised me is just how little fuel it takes to do so. Really, only a few drops will do for a short brazing session, and I found that the oil reservoir of my lamp was way larger than it needed to be. This simple technique revolutionized human art and democratized whole industries by making the incredibly high temperatures needed for things like glassworking or metalworking accessible to common people. The furnaces these lamps replaced once required whole forests to be harvested for fuel to achieve what only a few drops of olive oil or leftover cooking grease can do when invigorated with the blowpipe in a standard domestic lamp. After bending the ears and legs of the stand into shape, I filed and polished the soldered joints to try to make the finish a bit cleaner. In my last oil lamp stand, I built an adjustable holder for the blowpipe. While the pipe holder is occasionally useful, I found it annoying to have it directly attached to the lamp stand, as moving it caused the lamp to shake. More often, I found it better and easier to just hold the blowpipe in my hand. So in this iteration, the lamp stand will just be a lamp stand, without a pipe holder, though I may make a separate pipe holder for when I need a free hand. I filed some grooves into the stand's legs so that they would easily rest in just the right spot in the rings as I soldered them together. This job requires precise control of the heat, as if I'm too reckless, I could easily melt the joints I've already made, causing the lamp stand to fall apart. This is where the blowtorch really shows its versatility, as the size and shape of the flame are almost infinitely adjustable by the user, and can rapidly be adjusted to whatever the piece calls for, moment to moment. Being controlled by the air in my mouth, it's really all muscle memory to make the flame what I want when I want. One of the things I love is being able to immediately stop applying heat just by not blowing. When I used to use a modern blowtorch, needing to dial down the valve was a much more cumbersome task than what this lamp provides. If you watched my recent video on ancient Greek automata, then you may have already seen the oil lamp I made for this project, as I fired it along with my automaton's terracotta receptacle. This lamp is similar to my last lamp, but with a smaller fuel dish and a second, larger wick holder. I was really happy with the way it turned out, so after firing the pottery, I poured milk all over it. Terracotta is a naturally porous material, and won't hold liquids very well on its own. Artifact oil lamps from ancient civilizations, like Rome and Greece, contain traces of milk, which is evidence that these lamps would have had their purs sealed by being cooked in milk like this. The casein in the milk acts as a sort of polymer, along with the milk fat, to clog up the purs. After the milk seal was dry, I gave the sealed lamp a coating of linseed oil. Linseed oil is a drying oil, which means it will react with oxygen to polymerize and help seal up holes the milk missed. I found these combined methods to work great for preventing the terracotta from absorbing the oil. I also just really liked how the sealing process brought out the color and texture of the clay, and as I added the wick, I couldn't help but feel I was looking at a genuine ancient artifact. This second wick is an experiment in increasing the power of the lamp, though even it is a fraction of the size some glassworkers preferred to work with. The lamp works great as a lamp, and I want to see it melt stuff. But first, I'm curious what the large wick will actually do. Apparently, it can summon a raging inferno, which is nice, but to really control it, I think I'm going to need a more precise blowpipe. My new blowpipe is going to be exactly the same as my last, except for the nozzle. In order to get the extremely small size of aperture required by old glassworking manuals I've read, I'm going to try using a modern 3D printer nozzle. I recently acquired a copy of T.P. Danger's Art of Glassblowing, which is a manual from the 1800s which instructs the reader on the basics of lampworking, aka the practice of using a blowtorch lamp for glassworking, in Danger's case specifically for the construction of scientific glassware. Danger's book has been an extremely helpful source and includes a chart for sizing your blowpipe's nozzle to the size of wick you're using. As soon as I began to blow through the new pipe, its advantages were obvious. The flame was way more constant and steady than my previous pipe, and I don't think the lamp will give me as much trouble with soot now. But what's even better is it hardly takes any air at all to make the thing go, and can melt glass with relative ease, even with the smaller wick. This pipe makes circular breathing almost effortless. That is, I can breathe in and out through my nose while still breathing through the pipe with the air in my cheeks, meaning I can keep the torch going ad infinitum. The smaller nozzle even proves itself able to rein in the inferno of the large wick into a powerful pointed torch. I really want to see if I can actually work glass with this, so I'm going to build a clamp to hold my blowpipe, as glasswork will require both my hands free. Over the 700 or so years, from its appearance in the 13th century to its gradual disappearance in the 19th and 20th century, the blow lamp saw a wide variety of uses and developments. Along with the stands and clamps, Danger mentions a variety of amenities to the blow lamp, some of which are strikingly clever devices, which I hope to try to reconstruct in future videos to enhance this tool further. By the 1800s, the blowtorch was a common tool across a multitude of industries, and the lamps had gone from pottery to primarily copper or tin Betty lamps. Though the material had changed, these lamps were functionally identical to their earlier counterparts, with some small alterations. For example, some of these lamps did have a small plate or cap specifically for lampworking, meant to depress the height of the flame and reduce its smokiness. In his book, T.P. Danger specifically mentions this in the context of making it more pleasant for students to use in their small chambers. The idea of lampwork being a common practice for a student in the 1800s, so much so they'd have one in the room they slept in, struck me as a funny image at first, but really goes to show how crucial these devices were to the science and art of their time. I mentioned in my previous video on the subject that alchemists throughout history used blow lamps frequently, early on during the Renaissance for making their own glassware, but as techniques developed, the blow lamp became inseparable from chemistry and natural philosophy as a whole. The famous 18th century painter, Joseph Wright of Derby, captured this importance in his painting of The Alchemist, which depicts the German alchemist Hennig Brand discovering phosphorus. This painting is meant to depict some of the early modern period's greatest contributions to science, and in looking back at it recently, I couldn't help but notice the fellow in the back. On zooming in, you can see he is holding a blowpipe over a spirit flame, and in the other hand, a charcoal crucible with a puddle of molten metal in the center. This is almost undoubtedly a depiction of a saying with a blow lamp, aka a chemical process to determine the purity of metal. I'd be willing to bet our friend is testing the alchemical metal the alchemist has created to see if it stands up to scrutiny. The blow lamp is framed in this image in the same way as the mechanical clock and the completed globe, suggesting the painter sees these three discoveries as similarly valuable to humanity. The blowpipe holder I'm making will clamp to the workbench with a wooden C-clamp. Because it's physically separate from the lamp stand, it should be easier to move without messing with the lamp's placement. To make my C-clamp, I'm going to join 3 pieces of wood. I'm doing it this way because wood is strong across its grain, but fragile along its grain. Because the clamp will be C-shaped and have 2 90-degree bends, that means if it was made out of one piece of wood, there would always be 1 or 2 places where the wood is weak. I'm a little nervous to try to use this to work glass, primarily because I really haven't ever worked glass before, so I don't really have any idea what I'm getting into. But also because I still don't know if my wick is large enough to really do the trick. Typical glassworking lamps would have an inch diameter wick, or even larger. Mine is an inch wide, but only a tiny fraction of that distance across. It's possible I'll have to use a larger wick, as well as adding in a multi-headed blowpipe if I really want to work glass for more than simple operations. As I finish pinning together the clamp, I'm getting more and more excited to see what this thing can do. My blowpipe holder will work off the same principle as the helping hands I used for brazing. Just a mount attached to a bendable wire I can position where I want. I'll probably come up with something better in the future, but this should be good for now. To test the blow lamp, I'm just going to try melting the rim of an old test tube, and seeing what heating a glass body like that is like with this setup. Danger says that the flame for heating glass should make noise and have a licking tongue. However, he also says it should be clear enough not to deposit soot, which is a balance I'm having a hard time finding. That said, it heats the glass readily and brought the rim to a dim heat pretty quickly. I forgot that I was supposed to turn the glass in the flame, however, and the uneven heating caused it to crack. Interestingly though, I found that I could join cracks in the glass with a little shard of broken glass acting like solder. I found it relatively easy to melt holes into the hot glass, as well as just to join the shards of glass to the test tube all together, which wasn't pretty, but felt like a fun first try. Just for fun before I close out this video, I thought it would be cool to reproduce the scene in the background of the painting with my own lamp. So I made a quick charcoal crucible by boring a shallow hole into a piece of cherry branch charcoal. Then I just threw in a shard of copper to act as my stand-in for alchemical gold or silver. This tool really inspires me, and I'm going to continue to develop it and to practice the techniques for using it, as I can tell I'm only just scraping the surface of what's possible here. With that, I'm going to close out the video. If you enjoyed, please subscribe. I've got a lot of fun projects coming up, and I'm really curious to hear your thoughts on this one, down in the comments below. Thanks, and bye!